So the next type of strategy we're going to learn for solving a system is called the elimination method. It basically, if you haven't noticed, we have the graphing method when they're both in slope-intercept form. That's great, but you have to graph. Then the substitution method was when we had one in slope-intercept, one in standard form, and the elimination is when both of our systems are in, both of our equations are in standard form. So it's kind of up to you how you solve these things. I think each one kind of has its benefits, and it's solely based on how it's presented to you. So these are both going to be in standard form. So here's what this looks like. I've got two equations. They both have the x, y's off to one side, the constant on the other side. And these really aren't that bad if you're decent at multiplication. What I mean by that is what we're going to do, and if you notice on these, your x's are lined up, your y's are lined up, and then your equal sign constants are lined up. What we're going to do is kind of focus on one column of this, and we're going to try and get one of the variables to eliminate itself, to cancel itself out. So what you're looking for without using the vocabulary is you're looking for what's called a common multiple. I'm looking for a number that 10 and 20 both divide into, or that 3 and 6 both divide into. Now, these problems today, just to kind of get your feet wet and get you used to it, I picked problems where I can say I can take 10 and I can easily multiply it by 2 to turn it into a 20. Now, what I'm doing is I'm kind of looking at the two numbers on the x, and I'm deciding if I can use one number to cancel out the other. I feel like I'm not quite saying that 100% the way I want to, but so just kind of watch what I do here. I'm going to take the top equation, I'm going to multiply it by 2. Right? I'm going to, everything all the way through the equation, I'm going to multiply it by 2. And what that's going to create is a 20x, a 12y, and a 60. Right? Everything is still nice and neat and lined up. These are very organized. If you're a decently organized person, these are going to be a lot easier. Now, if you notice on my x's, I've got the negative 20 on top and the positive 20 on bottom. Well, I've set this up so when I add up my columns, when I kind of segregate these here and I add them up, if I add up my x column, the 20 and negative 20 are going to cancel each other out. When I add up the y column, well, that's just addition. 3 plus 12 is 15. When I add up my constants, 15 and 60, that's 75. And then I divide by 15, I get the first half of my answer. The y coordinate, the y value is 5. Okay, it takes a little bit of getting used to on these because it's not just you just jump in and do it. You kind of have to stop and think and figure out what the best approach is on whether you're canceling out the x's or you might be canceling out the y's. It just kind of depends. I always look for a pair of numbers where I have a positive value and a negative value. That way I only have to worry about trying to get the numbers themselves to cancel out. The second half of this, though, is very similar to what we did previously with the substitution. You're going to take that y value and I'm going to plug it into one of the equations where the y is at. Again, I try and steer away from negatives if at all possible. I try and look for the one that might be easier to work with. So I'm going to take this y value and I'm going to plug it back into my original top equation. So I still have 10x plus 6, and I'm going to plug in that y value of 5 equals 30. What you're building here is a really straightforward equation to solve, stuff that we were doing way back at the beginning of the school year. 6 times 5 is 30. Everything else drops down. 10x plus 30 equals 30. You're going to get a nice two-step equation to solve out of this. So when you subtract 30, you get 10x equals 0. Your x value has to be 0 for this when your y value is 5. Again, this is ultimately a point. These two lines are going to cross at the point 0, 5. Okay, now today I've kind of handpicked these problems so that what you're looking for is one equation that you multiply by a constant to get a canceling value in the other equation. You can, and you will ultimately, tomorrow you'll have to multiply both equations by something to create this canceling effect. But this one here, very similar question. The 10 and the 20 are kind of poised for you to cancel out. However, they're both positive. So what that means is when I take this second equation here, multiplying it by 2 doesn't quite do the job because that'll create a 20 and a 20 that won't cancel out. So I need to, again, think just a little bit. I'm going to multiply it by -2 to create a -20. So my top equation is going to stay the same. My bottom one is going to become -10x minus 20y equals -50. And I've created that situation right here on the y's where when I add them together, they cancel out. So if I go back and add up those columns, I get a -6x, I get nothing for the y, and -54. -54 for my constant. Divide out your -6. My x value is 9. Now, when you do the second part where you plug that back in, notice you're not always solving for the y or always solving for the x. It's flip-flopped on us here. Pay attention to what variable got solved for because this value is getting plugged in for the x this time. And I can plug it into either equation. I'm going to plug it into, let's just go for the bottom one. So I'm going to plug 9 in for x. So that's 45. Everything else in this equation stays the same as you're solving it. When I subtract out my 45, that's going to give me a -20. Divide out your 10. Your y value is -2. So your solution, your point is 9, -2. I'd like you to try, the homework has 4 or 5 questions on it. Try one. Okay, I realize that this is kind of a big concept for a Friday when I won't physically see any of you guys. Try one of these problems, or if you want to try them all, but try at least one of these problems and bring it in on Monday and let me see it. If you're one of the remote students, try one, take a picture, send it in, and I'll get you some feedback on that before you try the rest of them. On Monday, or whenever you're watching this video the next day, we're going to look at what happens when you can't just simply multiply one equation. You kind of have to tweak both of them. It's a very similar process. Once you get your new equation set up, the rest of it's the same as it is right now.